Hello, everyone. I see there is a lot of people for this mobile presentation, which is really great. We have today a lot of people actually talking. We have two of us talking with Eric, and we have two guests showing some stuff. And so let's start. I'll give a short overview of the presentation. So at the start, Eric will talk about the state of affairs on the Android. Afterwards, Mark will share his experience of porting from iOS, existing game from iOS to Android. And then we'll show some really cool looking RPG game running on the iPad. And afterwards, I'll finish up with talking a little bit what changed in the hardware during the last 2 years, and a little bit about the OpenGOS 2.0 and what can you expect now from the modern iPhones, basically, and what performance and well, basically what can you do with it. So, and I would like to invite Eric Hemming. He joined Unity. He has a prior console background, and he was working on many AAA console games. And now he's leading Android effort at Unity.
So, yeah, a lot of people here. So, as Ray just told you, I'm Eric Hemming. I'm with Unity Tech. I'm the lead for our Android department, and I'm going to talk a little bit like an overview of an overview of the Android support in Unity. Basically how Unity works with Android, a little bit about the device requirements, a little about the differences between Android and iPhone, and something about the Android market and plugins, which could be interesting to a lot of you, and some things about the future. So, Unity with Android. So the 3.0 release that we released like a couple of months ago, it brought Android support. So we decided to call this a preview. Well, primarily because there are some features missing that we would like to have in there to call it a proper Unity experience. So we just released 3.1, which is basically the release is mostly about the asset store, of course, but we added some critical fixes, some features that we needed to get in there for the Android. But we're still working on the final release, and of course, there's a couple of months out for getting the final version there. But but primarily we're missing the Unity remote, of course, and some other minor details. But there are already like games published to the Android market that use the Unity, and so we think it's stable enough to actually be used successfully in production. So why we did this and why now? Well, a year ago, Android wasn't really a hot topic. There were basically no good devices. The Android OS was not mature enough. But today, this is completely different. We have like between 10 and 15 device models that run Unity successfully, and the Android OS is much more mature today. And of course, the projection is obvious. I mean, in the future, we will probably see a lot more Android and a lot more interesting devices. And this is, of course, very interesting to Unity and should be interesting to you too. So our current device requirements, they may seem a little bit arbitrary, but I will come back to that a little bit later, why the current device requirements are. Basically, we need a Android OS 2.0. And it's the sort of the second generation Android OS, and there are some updates there that are crucial for us. And we need a good CPU, an ARM v7 CPU, and of course we need a decent graphical, like 3D graphical board. We require OpenGlass 1.1, but most of the devices which already are running in an ARM v7 processor, they are OpenGlass 2.0, so it shouldn't be a problem. So how does this compare to the iOS? Actually, the low-end Android devices, which we currently support with Unity, they are quite powerful. They are basically on par with the third generation iOS devices like the 3GS, and then of course scaling up from that. So what does this mean in terms of fragmentation? Fragmentation is not that bad as you might expect with the whole Android compartment with devices. We're basically limiting it to make sure that your applications will run decently on all devices. So feature-wise, the fragmentation is not that bad. All devices support almost everything across the board. But of course, there is a hardware fragmentation because you have a lot of different device vendors or device manufacturers. So there is a fragmentation to a certain degree, especially on the GPU side, where you have like basically three different paths of GPUs. But we've done some testing with real live games, and it's not that bad. The games run with basically the same frame rate on all devices, so it's actually not that bad. Another key difference between iOS and Android is that we use just-in-time compilation for the scripting, while on the iOS we use ahead-of-time compilation. So this means that we don't need to integrate it like on the iOS. We integrate it into Xcode, and you need to basically do post-processing in Xcode. We don't need that on Android. We can create the final distribution archive directly from within the editor. And then, of course, the Android market is quite different from the App Store. So I know that Mark will talk a little bit about that. I will just touch on two different aspects of the Android market, which are interesting well, good to know about, basically. So the first, the filtering mechanism of the Android market, and then the application licensing part. So the market filtering takes care of basically showing only the applications that your device supports. So it does this by basically you select the minimum SDK framework version, which is basically the OS version. As I told you before, we're going with OS 2.0. And then it's the CPU characteristics. And this is very high-level, broad filtering mechanism. Either it's ARM v5 or it's ARM v7. And there are a lot of ARM v5 devices which are not capable of running Unity because they're basically too old. So therefore, we went with the ARM v7 because that sort of makes sure that the application will run decently. And of course, then you have the OpenGLES version, which is 1.1 or 2.0, depending on which path in Unity you use. There are other market filtering mechanisms that could be applicable for your applications, but these are the three that are needed from a Unity point of view. The other thing is the license verification library. So this is a sort of it's not a copy protection thing. But it's sort of preventing piracy on Android. So it's a server-based verification. So which means that you need to have an online connection to verify the license of your application. And this is for paid applications only. And basically what it does, it asks us, the Android market server, if this application is actually bought by the user account on the device. And then it's up to you as a developer to basically act upon that. Maybe you decide to show ads instead of having like the no ad version, or you decide to not let the user play at all, or maybe like a downgraded version. This is basically up to you how to handle that. We expose that through the script API, piggybacking on the iPhone API, using the is application genuine and is application genuine available API. Oops. Go back a little bit. Yeah. So the Android OS, as you might know, it's completely Java only. The SDK framework is Java only, which means that as soon as you want to access input from touch input, or set up the screen, or play some audio, you have to go through Java. But on the other hand, Unity is completely raw native C++. So for this to work, we use something called Java native interface, basically across API, going from both Java side to native and back. So this is, of course, mostly interesting to us because we're the Unity developers, but it is interesting to you as well if you want to use plugins. Because with plugins, you can sort of customize the application experience on the device. Maybe you're not looking to have this all-out 3D environment in your application. Maybe you want this as a part of a bigger application. All this is sort of up to you to customize. But when you do that, you need to basically write at least part of that code in Java. And the other thing is that it brings the possibility of integrating third-party libraries into your application, like ad libraries. So there are 3 levels of plugin integration in Unity Android. First one is, of course, the native code integration, which is very similar to what you have on the standalone. Then you have the Java code integration, which is basically, extending our Java code with whatever you want on the Java side. You could use it from scripting, but you need to go through a native layer to get to the Java code. You can basically see it as Unity sitting in the middle of your script API, scripting on one side and the Java on the other side. So you need to go through native code to reach the Java code. And then you have the Android application resources, which is basically icons and whatever extra resources that you want in your Java on the Java side. So the future. I already touched on the Unity Remote topic. We will, of course, bring that to Android. It makes so much sense to have it there. We will try to broaden in the device support, because we see that there are device models which are not ARMv7 7 coming out, and they are still quite good, so they should be able to support your applications. So we will try to broaden that. Of course, optimizations. Some of you probably already tried the Unity Android and probably already know about the load speeds. We need to improve on that. Frame rate generally, of course, and also memory footprint, both runtime and on device, on the internal phone memory. So script API normalization is another thing. Currently we're piggybacking on the existing iPhone API. We're bringing a more generalized mobile API there. It makes a lot more sense. So we will also improve on the plugin support, because there's still some work that could be done there. So I guess you have some questions. I think we will take them at the end of the whole presentation. And if you want or have any more detailed discussion about Android, please schedule a hands-on session and we can go through them. Thank you.
Okay, next will be Mark. He's from Game Resort. And just 1 second. Yeah.
All right. Hi, everybody. My name is Mark Andrioli. I'm one of the founders slash developers slash man of many hats at Game Resort. And I'm here to share with you a few things we learned while porting games from iOS to Android. But yeah. Can you hear me? Oh. Before I begin, a quick introduction to Game Resort. We started 2 years ago as a two-person game developer. Our first game was a web game made with Unity, of course, called Downhill Bowling, which we ported to the iPhone, and we've mainly been focusing on mobile development since then. This slide shows a quick overview of our main project so far. It's starting on the left. You see Downhill Bowling, both on the web, iPhone. Then we had a few more games, Biplane, Flip Cup, Castle Warriors, and Doodle Bowling, which have been ported to bigger screens, both on the iPad and Android. And little plug here in the top right corner is our latest game, which is called Downhill Bowling 2, which will be released in on December 1st. But that's enough of the self-promotion here. Let's get started. The first thing you'll notice when you're moving from iOS to Android is there is a slightly intimidating number of available handsets. And so your first task as an Android developer is going to be to pick the right handset, or handsets, plural, the more the better, I guess. But you really have to see what makes sense to you. You have to factor in cost and how much time you can actually afford doing proper testing. Fortunately, Unity has some basic device requirements. We heard them from Eric just a minute ago. That will help you sort through the jungle. And the downside is, of course, you can't target, all the wristwatches and toaster ovens and whatever. But it will really dramatically cut down on the issue of handset fragmentation, and unless you really focus on the handset that properly support the technology. So we've heard about the basic requirements before, just another recap. So you need Android 2.0 or above. On some devices, I guess it's going to be 2.2 or above, because there's some issues. I guess I don't have to go too much into detail here. The other one, the architecture, ARM v7 or better. Another thing that's very useful that we learned from Eric is there is this online database called PDADB.net, where you can look up pretty much any specs for any devices. And if you're looking for a specific device, you're not sure if it's going to run Android or not, you can double check there and get your basic specs. And of course, the forums are always a good place to get information. So even with those requirements, you still have a tremendous amount of choice. So another way to filter it down some more is to check device popularity in sheer numbers, of course, but also see what carriers are up to and which handsets they might be promoting. That might be a good way to get exposures. For example, our game Castle Warriors got demoed in a preview of the Samsung Galaxy Tab on some Swedish website, alongside with some really famous games like Angry Birds, Fruit Ninja, Mini Squadron. And in itself, we probably won't sell too many copies on that device. I mean, I don't know, it could be really successful. But this exposure definitely helps on a promotional level. So once you're all set up with your handsets, you can start porting. And one of your biggest tasks when porting a game from Unity or in Unity from iOS to Android is going to be to deal with different screen sizes. And the illustration here shows our game Castle Warriors on the iPhone in the center of the screen, and then in the background you see kind of the width of a typical Android screen. It's a little cut because of the format of the presentation, but it gives you a feel of the difference in sizes. And this might seem like quite a step up, but in reality things are not too bad. So, because first of all, if you're making a 3D game, content will just scale, and textures are usually pretty forgiving when they're being scaled up a bit. So all you really need to worry about are the 2D graphics, as you might use them for the user interface or for in-game sprites. But there's good news there too. So if you're working on iOS projects, chances are you already have these higher resolution assets created to support iPad or Retina resolution versions of your game. On Unity supported Android devices, the most common screen size is probably 854 by 480, which is close enough to Retina display on the iPhone or even the iPad. Unless you're super meticulous, you should be okay with just 2 sets of 2D assets. So one that's a regular iPhone resolution, and then create a version that's twice the size, which we can call 2x, just for all these other devices which have higher resolution. Over the last few years, we've seen that there's been a big increase in mobile screen resolutions, and there's probably one more step, which is a true HD mobile device supporting 1080p, which is 1920 by 1080, and this could come potentially in the shape of an iPad with a Retina display, or I'm sure all the handsets manufacturers have probably something coming up. So once this happens, you might want to bump up your assets even more, but that's probably it. I mean, it doesn't make sense to go beyond a certain resolution given the physical size of the devices. So what are some of the strategies that will help you cover your bases to deal with different screen sizes? So the obvious one is, well, create high resolution assets from the start. It's much more easy to scale something down than to scale something up. So currently plan at least a 2x version compared to the iPhone, and then if you want to be safe moving forward, for example, if you want to also port to I don't know when it's going to come, but the Mac store, like Unity, I guess, will maybe support it. You might want to work at a 4x resolution to be really safe. So instead of creating a button at 32 by 32 pixels, you should create it at 128 by 128. It's not much more work up front, but it will save you a lot of headaches down the line. Yeah, don't hard code UI elements. Make your user interface as dynamic as you can, I guess. There's probably always going to be some small adjustments. It's hard to have a system that just takes care of everything, but you don't want to redo your user interfaces or game layouts every time. And you can create, I guess, the closest to get there, I guess, will be to store all the different screen size assets in a single build, and then at runtime the app would check the screen size, and you kind of, if you're well organized, you pick the right bundles, and you can assign the right assets to that running game or application. So now a few things to watch out for. Bigger screens don't just require bigger assets, they also introduce some performance challenges. And again, this applies to porting from the regular iPhone to iPad or Retina display. But just in case you haven't dealt with bigger screens yet, just a little heads up. So the faster processors of the new devices don't really compensate for the larger number of pixels that they need to handle. So displaying an image on a Retina display, for example, or a typical Android screen, is like displaying 4 regular iPhone screens. So you really have to keep an eye on your fill rate. Overdraw is an issue. It's really increasing your fill rate exponentially if you're not careful. So yeah, be careful with large blended objects like particle effects or vegetation if you have something crazy like that. on your mobile device. If your scene looks like anything on this illustration here, then you might be in trouble. This is a fire particle effect that we used in Doodle Bowling as a background filler, but on the bigger devices we had to scale it down so to reduce that overdraw. And yeah, fog is a killer. It's a little ironic because traditionally fog has been used to optimize 3D scenes, and because you can really bring in the clipping plane and reduce the amount of geometry that's stored on screen. But in this case, it can be a real performance killer, and we haven't been able to use fogs in any of our ports to the bigger screens. I don't know if there is a way to deal with that, but well, we just decided not to go with any fog. Finally, a small thing, but when you switch from one project to another, like if you switch from iOS to Android, your Unity will assign different presets to your art assets. So make sure to double check your art assets. Make sure they're in the right format. Like some assets you don't want to be compressed for the user interface, for example. So you make sure you check all these little boxes and all the different formats. So we pretty much covered the art side, but what about scripting? So the good news is it just works. After we finished Downhill Bowling 2, which we just did a couple days ago, we did a real quick build, and it just worked the first time on Android. We didn't have to do any scripting changes. However, you have to be careful. If you use any external codes, any plugins like for social networks like Facebook Connect or OpenFaint or anything like that, you're going to have to obviously adjust that for Android. If you're coming from iOS, there's going to be slightly different ways to tie those in. And also a small disclaimer, I guess. Even though most of your porting work is handled by Unity and it just works, you still have to test on a real device all the time and really be sure that your game runs properly. Yeah, handset manufacturers can be pretty inventive in introducing little quirks and just to see if you're paying attention. Yeah, and we like pandas, so I couldn't find any better illustration for scripting. So just went with this one. Yeah, so once your game is ready, it's time to ship. So how does that work? Becoming a publisher on Android is really simple. All you need is an Android account, which costs I think just $25 to register, and a Google Merchant account, which is where you will get paid daily if you have a paid app. As soon as you submit your app, it's live in the store, and there's no approval, so your app shows up immediately. The flip side is there is no safety net either. So if you mess up, you probably hear it from your customers directly. Fortunately, it's also easy to fix a problem because you can just instantly resubmit a new version. So the whole experience is very different from the App Store. One of the big limitations on Android is there's a 25 megabyte per app limit, so something to plan around, I guess. And there's this policy that you can return an app within 24 hours if you're not happy with it, and you can do this straight from your device. So we've seen people buy an app and then before the 24 hours they would return it and then buy it again just to extend that period. But in general, there's very little abuse, and it seems to be a pretty reasonable policy to have in general, because yeah, you don't want people to not be happy with your game and still have to pay for it, or worse, have it on the device and that device is not supported for some reason, and then you have a big headache to reimburse them. This is my last point, but it's probably going to be your biggest challenge as a Unity iOS developer moving to Android. The dynamics of the Android market are very different from the App Store. And while the App Store favors impulse buys with its nice virtual shelves and gift cards and shiny features and all that, The Android market relies on a pretty bare bones app listing, which is organized by Google's algorithm, which in theory should make sure that the cream rises to the top and does so objectively, but in reality it's still the apps that have the biggest exposure that make it to the top. And it's just that this exposure doesn't happen in the store, it happens outside of the store on Android. There's still a few featured spots on Android, on the Android market, but it's nothing compared to the App Store, and it's even more difficult to get there. People are complaining on the App Store that it's a bit of a lottery, but on Android it's very tough. And so while the App Store can generate winners and multiple winners, you really have to do your marketing outside of the store on Android. Pricing is another tricky subject. So it seems like most publishers are going the free route. Ad-supported applications are pretty big, which kind of makes sense when you look at the Google ecosystem, which everything tends to be free. We have both a paid app and an ad-supported app in the market, and so far both are doing about the same in revenue, but we're still experimenting, and we haven't really done any big marketing push because I guess we still have a pre-release version of Android on Unity. Carrier stores could be a very big thing. It could be the next big thing actually for developers, especially for paid titles. There are more opportunities to get featured. Carriers are well known for their marketing prowess, and if the traditional cell phone gaming market is of any indication, you can expect to see the featured games do very well. So just a quick recap. Pick the right device, focus your effort, and test efficiently. You won't be able to cover it all, so or test it all. So you just have to focus on the big handsets. Develop for multiple screen resolutions. This is true for any cross-platform development. Create at least 2x assets compared to the iPhone, 4x to be safe. The app limits, just keep it in mind or suffer the consequences, I guess. Unity scripting just works, which is nice. It's the Unity magic, but you have to deal with native code. And understand your target audience and the market dynamics. Be aware of cultural differences between user groups and between stores, and you will have to adjust accordingly. But thanks.
Thank you. Right now, Jason is coming on stage, and he will be showing a game. Basically, it's a Arlan, quite.
Sword and Shadow, yeah.
Sword and Shadow, thank you. So it's developed in partnership with the Crescent Moon Games. You probably seen the Raven Sword, and then released the Rhinelands, the Thor Hammer. And for me, it's very. It's a surprising game because it's quite a big environment. Usually, you don't see that type of games with Unity. And it would be interesting to Jason will show a little bit how the game works, and he will talk a little bit about the technical details, how it's implemented. So,
Sorry. Can you grab that piece of paper right there?
Yeah, sure.
Up. All right. Try to transfer up there a bit then. Okay. Hi everyone. My name is Jason Jones. I'm with Glue Games, as he was saying, and partnered with Crescent Moon Games on the 3D RPG we're creating called Arlan, Sword and Shadow. It's if you've seen Raven Sword, it's kind of like Raven Sword. Kind of to magnitude of 10 probably as far as world size and the amount of things you can do in the world. So it's been a pretty big project, and it's kind of inspired by some of the large RPGs we've all seen on PCs before, like Morrowind, Oblivion. World of Warcraft even has some of our inspiration, I think, and we wanted to figure out a way to bring that kind of game to a mobile device, and Aerolon was kind of the result of that. So the big questions, with the mobile device having a very large world, a really immersive world, those are kind of key features for RPGs, and of course the 3D environment too. We wanted to make sure we recreated that immersion factor using 3D. So those were the big challenges we faced creating Aerolon. I'm going to try to just bring it up here and see how it looks on the screen. Let's see if I can load. So the first thing we wanted to tackle was those large levels. How do we create a big 3D environment that still runs at a good frame rate on the mobile device and has a lot of detail at the same time? And so we turned to Unity to do that. Unity is great because it's so flexible as far as what you can do. Unity allows editor scripting, which we used a lot to kind of optimize things and to determine things programmatically that would be very hard for the artist to determine. But I'll just show you a quick run through of what we've created here. You can see here we have it's Unity Mobile, as you know, probably doesn't have a terrain engine like the desktop version, so we had to kind of start from the beginning with how to create a 3D terrain system. So we created the terrain was created as like one giant height map for the entire world, an external tool, and then we using 3ds Max and other tools, we kind of subdivided those tiles into smaller tiles. I think we had 16 tiles, world tiles, to start with for the external world, and then we started splitting those down and then assembling 2 or 3 at a time into an individual Unity scene. And then again, within that scene, we then used Unity scripting in the editor to subdivide those tiles into optimized geometry blocks for efficient culling and occlusion culling. So you can see here's some of the stuff. This is one of the opening levels of the game here. You can create. It's all pretty much dynamically lit. We wanted to have that dynamically lit effect, and one of the big things we wanted was a day and night cycle. So if you're going to have a day and night cycle that's going to change throughout the day, pre-baking your entire environment is not really going to be effective. So we went with a dynamic lighting model, and we've been pretty pleased with the result. Unity's performance has been excellent all around. So there are several tricks and stuff you got to learn with the shaders, and may have to optimize geometry in certain ways. You can see that the frame rate here, and you can see it's much crisper, obviously, on the device itself, but you can see the detail level of the geometry and the open world feel. I'm going to show you real quick, the day and night cycle. Let's see. I'll wait and show you on the actual device here, but you can see the sky is getting dark as time goes on. We also have this we use a lot of Unity layers because we can set up geometry in different layers and have different cameras that render different layers, and so we use that a lot to control what geometry is rendered when, and moving stuff in and out of layers, and having some layers like the base terrain is rendered at a much greater distance than some of the more lower level detail objects. Also, when you see little tiny things on the terrain like this, like the flowers and plants and grass, we have all of that stored in like a custom mesh format that's loaded at runtime. And because if you try to just put all those objects in the scene, it's not going to work. You've got to have some kind of way of managing that. And so we have an internal spatial structure that manages all that geometry and can load up the geometry that's nearby, as you're running through the world. Let's see if I can show this day and night cycle running here. We also have pretty detailed character customization, which is a big feature of RPGs. So here you see this is my other character was a female mage. This is a troll warrior, and he's standing somewhere you're not supposed to be able to get to, but I put him here just for demo purposes. So it's going to speed up time here, so I can show you the day and night cycle as it goes. This will normally take 24 minutes in game time, but I think I've sped it up significantly here. You see the sun and the moon, etc., will rise, and on the entire lighting of the terrain and all the objects are changing with it, obviously. We have also a character customization, via mostly a prefab-based system. So we have different prefabs you create within Unity for different heads and different base models, player models, and hairstyles, and then you also have a dynamic texture loading system for equipment. So if I equip a new shirt or a different set of pants, it's gonna load that texture from the resources directory, upload it to the graphics card, all on the fly, because there's no way you can load all these resources ahead of time on a mobile device. But Unity lets you access the resource directory and change assets on the fly. So it's been that's pretty much how we created all that. Let's see. I just want to show a couple of tools in the editor as well. If you can switch back over to my desktop. It seems to be a lower resolution here. So one of the things we created was a custom tool using the Unity editing scripting again for placing grass and stuff like that. So our artist is able to just quickly assemble any set of prefabs that he wants, and then set up one of these custom objects in the editor, and then place different objects. They could be any prefab in the game. Basically, you can use this tool to place throughout the world. So we also use a lot of editor scripting to kind of define game objects that exist in the 3D world. So you can see some of our widgets here defining object points and NPC spawn points, that type of thing. Some of the challenges we face, the biggest ones, again, are probably performance, as far as having a large world with a lot of detail. Takes a lot of textures, which takes up memory, of course, and a lot of customization requires a lot of dynamic loading as well. So that type of management, memory management, and asset management, you've always got to watch your memory and and of course your frame rate. So using the terrain detail system and the spatial hierarchy really helps us to optimize. We only send what really is visible, immediately to the player, to the graphics card, because on a mobile device, you don't have the fill rate to spare, and you don't have the CPU to spare either, really. So it's a very tricky balancing act sometimes. We also use a lot of physics-based triggers. So as you move throughout the environment, you're going to see. I don't think it likes this. As you move through the environment, you're going to you basically have a trigger system that's based on where you are. That's going to constantly activate and deactivate objects as you move around the world. But they're only the things that are nearby are actually taking up resources, etc. So, anyways, you can get an idea of what we built here. And I said I'll be available afterwards if you want to ask me any questions or see the game running on the device. I'm happy to show it to you. This game is not released yet. It's still in development, but we're getting pretty close to the end here. So we're planning to have it in the store before Christmas this year. So that's all. Thank you.
Thank you, Jason. Sometimes when we look at the games, for us it's hard to believe that it's made with Unity. Okay, let's continue now with the iPhone stuff a little bit. But it is somewhat relevant to Android and native client too. So let me see if that works. And basically, I want to cover changes from iPhone from the first generation and second generation, which came out probably 3 years ago. And we released the Unity 2 years ago. So it's basically 2 years ago, that was the main device everyone was targeting at. And it's iPhone and iPhone 3G and iPod Touch. And then, if you look back at that time, the GPU was MBX, and it didn't have any pixel shaders. And the ARM CPU, you can see the frequency, and it was more 128 megabytes of RAM. And we were recommending following numbers. So it would be around 7,000 to 10,000 vertices in the view, in the frustum, and approximately 5K of skin mesh vertices. And after we implemented batching, we would recommend around that number of objects on the screen. So. And let's take a look at the third and fourth generation of devices. It's basically iPhone 3GS. Across all the family, across the third and fourth generation, we have a SGX, which is basically a modern level GPU. It has quite a lot of flexibility, somewhat comparable with the PC, not comparable on the performance level, of course, but feature-wise, it's pretty decent GPU. So for the CPU, we have an ARM Cortex, which is clocked differently on the basically A4 inside has the same Cortex A8. It's a little bit modified to get up to 1 gigahertz, but the idea is basically the same. So you see the significantly faster CPUs, and the memory increased a lot. So, and today I want to talk a little bit what you can expect from the Unity and what you should expect from your games when you are targeting these devices. There's more and more devices. I'm pretty sure there's more third and fourth generation of devices nowadays. So, memory available for your game. Back then, you would have 35, 40 megs before the game would basically crash. Right now, if you're targeting iPhone 3GS or iPod Touch, iPad, it's 120 megs. So it's more or less half of the memory. You have the physical RAM, half of it you can use for a game. The rest is operating system, Safari, and I don't know, stuff. For the iPhone 4G, you have even more memory. It's more than 200 megs. So basically, we just tried to allocating memory and see when it crashes. So it was more than 200 megs you can use. So there is a plenty of memory for your assets for those games. And basically, the recommended budget we would recommend right now for the iPhone 3G S and for the iPhone 4, it would be around 40,000 vertices, around 15,000 skinned mesh vertices. And here is the character. It's actually 3 characters running on the iPhone 3GS. They were running around 30 frames per second, and that's the same character you've seen in the bootcamp demo. And we can have 3 characters like that running on the iPhone 3GS. And they are roughly around 12. I don't remember exactly. It's like 12K each character. So in this particular case, it was almost more than 40,000 triangles, just skinned vertices. But in real game, you probably don't really want to take that much time for your skinned characters because you have a gameplay and stuff like that. So usually we would be saying for the budget, that's the numbers. And because the CPUs are much faster and the drivers are significantly better than they were 2 years ago, you can actually push more objects as well. So basically, the only thing you should be aware of is the higher resolutions of those devices. Yeah, so SEAL approves as well these numbers. So a short recap on that. So that we have significantly more power on the CPU side. So more, basically, it's a more objects, more skinned vertices, more physics and more gameplay stuff. Much more memory, and you can push much more vertices than you could with the MBX. However, on the pixel side, you have much more flexibility. You can write pixel shaders, but the memory bandwidth itself didn't went that high. And though you have a much more power on the GPU for the pixels, if you go on the higher resolution, like the Retina display, or you're talking about the iPad, you don't have that much power per pixel. Okay, let's look a little bit at the SGX. So the main difference, it's fully programmable. So you can have vertex and pixel shaders, which is nice. It's still tile-based architecture, same as MBX was. So basically, what does it give you? It gives the hidden surface removal. And for example, you can see how well it works. For example, if you have a scene which, for example, you have a very complicated shader, you can just have a lot of layers of the blended geometry on top of each other, and you would see that it's very slow, and it takes 10 frames. It's running at 10 frames per second. But then if you cover half of that screen with the box, just the user box, you would see that the frame rate actually goes up. And in theory, you increase the overdraw. But in reality, because this cube, which is opaque, it allows SGX to kill all the stuff which is behind it. So you can cover parts of your screen with a very big object, and if they are cheap, that even can help you saving performance for a much more complicated shaders, which are not visible most of the time. Alpha testing is still as expensive as it was on MBX, so you should try avoiding it as previously. Actually, in the 3.1, we added a special render queue. If you know the render queues, they allow you to sort objects on the coarse level, and we had previously basically the background, the opaque and transparent stuff. So now we introduced alpha-tested stuff in the middle. That's in order to help. So we basically, now Unity would render first opaque objects, then it would render alpha-tested objects, and then it would render usual alpha-blended objects. So we try to increase hidden surface removal as much as possible. And another thing which is very interesting about the SGX, it's modern in this regard that it has a dynamic workload balancing. So if you have less vertices in your scene, that means that you can have a little bit more complicated pixel shaders, maybe. So you can try balancing. If you're having very simple shaders, then you might be able to run with more vertices, because the GPU internally will allocate more cores or more basically transistors to work on one or another task. And that is done automatically. So in Unity, there are 3 ways now to write shaders if you are targeting iPhone 3GS, like third generation of devices. And the new thing is surface shaders. It is the most simplest way to do it, and it's very cross-platform, and it's basically a very small amount of code. The next possibility is CG. It's as well cross-platform, and it allows you a little bit more control take a little bit more control, you will need to know a little, much more about how do you write your shaders. And the most hardcore way would be using the GLSL ES, which gives you the full control. But unfortunately, it works only on the GLES 2.0. So you won't be able to have the same shader running in the web, for example. You, of course, can mix and match, and you can have a CG for your web, or you can have a surface shaders for your web in the same shader, and then have a subprogram which is using GLSL ES specifically for the iPhone or Android. Okay. A little bit about the GLSL ES. The difference between the OpenGL implementation and the OpenGL implementation, normally in the OpenGL implementation in the GLSL, in your shader, you have no constants at all. In the OpenGL version, you have these built-in constants, which are coming directly from the engine. So we on the iPhone, we decided to simulate that. More or less, that is the list of things which you expect engine to provide. So in this case, you can more or less, without much pain, just take your usual GLSL shader and move it to the iPhone. And in the most cases, it will just work out of the box. And then you can start optimizing on that. Right now, our documentation is not superb on that, and I think in the next version, the next release, we will have much better documentation concerning how do you write GLSL specifically for the ES 2.0. So if you know that there is no fixed function in the OpenGL 2.0, so in order to solve that, because we have a shaders, the shader lab shaders, where you can actually write the surface shaders, and we wanted you to be able to use them on the iPhone. So what we did is we implemented a fixed function emulation, which basically grabs a state texture combiners and generates GLSL at the runtime. And basically, the first time you render an object with the new shader lab fixed function shader, it will just spit out the GLSL, and it will use it for the further call. When you are rendering this object again, it will be using the same GLSL generated internally GLSL shader. So there's a couple of things to watch out is that generating GLSL shader might take some time. Then compiling it takes time as well. And that's what driver is doing. So ideally, and that happens, of course, on the first time when you render that object. So ideally, you would like to do that as early as possible. And maybe try out, like, if you have different objects with different shaders showing up late in the game, maybe you want to show them during the first frame covered with something, so you know that the shaders are generated and compiled. And there is a list of things which actually will trigger a new compilation. So it's a lighting change, alpha test, or fog mode changes. So just watch out for that. Actually, if you look at on the GOS 1.1 on the new devices, the driver has to do exactly the same. So sometimes you can see that even on the GOS 1.1, if you're using GOS 1.1 on the new devices, there's some hitches when the new objects are appearing. They're quite hardly noticeable, but they're there, and that's because the driver has to do exactly the same as we are doing in the GOS 2.0, simulating the fixed function shaders. So if you are looking at the performance, in the 3.1, we added a new statistics for the internal profiler, which it's called CPU weights for GPU, and basically it does what it says. It shows you how much time the GPU is over the CPU, how much time GPU is spent on the GPU comparing with the CPU. So if you see this number going up through the roof, that means that you are GPU bound. And most probably on the iPad and using the Retina display, you will see those numbers going upwards. And that just means that you need to optimize your shaders or render less stuff. We actually measure that by measuring the first draw call. That's where the GPU, when the CPU is waiting on the GPU, it's on the first draw call. So we're really happy with what Apple is doing with the iOS 4.x. There's a lot of optimization during the last year, both internally in the driver, and there is a very interesting extensions which are coming out, and we are starting to use them, and we see significant performance improvements. And one of the things they improved GLSL compiler a lot recently with 4.2. So it might be useful to actually encourage users. If you check for the OS version, and if you see it's a 3 point something, then you might maybe encourage user to, like with some text, go and upgrade to OS 4 point something, because it will improve performance in many cases. So again, things to watch out: the higher resolutions, that's very no-brainer basically. The higher the resolution, the slower it will get. So another thing is sometimes you are using existing shaders from the desktops, and then you might notice that the stuff which was working previously per vertex now is per pixel. And there is a very important concept in when you're writing pixel and pixel shaders now. It's a shader precision. And basically how it works is you have 3 types. We just exposed that. I'm not really sure if it's in the 3.1. Maybe it will be in the next version, but we exposed RS implemented support for the 3 types in the CG, which is fixed, half, and float, which will be converted to the so-called low precision, medium precision, and high precision in the GLSL talk. And what does it mean, basically? In the most hardware, on the iPhone and on the Android, that would mean that the low precision stuff will be, the hardware can do 4 components. Like if you have a vector, then it can do 4 components per cycle. If it's a medium precision on your type, then it will have to do can do only 2 components per cycle. And otherwise it's 1. So basically, if you're using high precision, then it can be up to 4 times slower than the low precision. And what this precision means is basically how many bits there are per component. So the rough guide is that if you are using sampling usual diffuse textures, colors, or using normals, then it's enough to use low precision. Usually it's around 12 bits per component. For the texture coordinates, you would need medium precision and high precision for sine, cosine, like very algebraic functions, which require a lot of precision. So in general, you want to move your stuff to have shaders using as low precision as possible. And that can be a tremendous performance increase in reality. You can do post-processing effects, but just don't try using the standard ones. You need a very small resolution buffers if you want to get it at 30 frames per second, and you must hand optimize them. And then it's definitely not for the Retina display. I probably will. We are running out of time, so I probably will skip the multi-sampling. Anti-aliasing, I just mentioned that it probably makes sense to use it on a 3GS. And it's more efficient than just doing a rendering at a higher resolution. So if you're targeting the Retina display, then on the 3GS it might make sense to go with the multi-sampling, because then you would get somewhat comparable visual quality. And yeah. And a short recap of what's in the Unity 3.x. The new things, it's of course unified editor, you know that. We exposed plugins, so everyone can use that now. Previously it was only Pro version. And there's one thing I just want to mention is the PVR importing, so you can drop your PVR texture. You don't need to. If you have sometimes the PVR, some people are noticing bad quality in the PVR textures, especially if they're using alpha channels. Sometimes it's easier to. Sometimes you can get a much better quality if you're using Imagination Tech plugins in the Photoshop, or if you're using external tools to compress it. So you can compress texture to PVR format, and you can just drop it into the assets. And Unity will grab it, and it will not do any compression afterwards. So it will be used directly in your game. Yep. I think we can wrap that. And yeah, do you have any questions? Yeah.
On the Android, they mentioned the 25 meg limit. Is that for the core app, or is there? Have you had any experience with using the core application and then pulling in data separately?
So that would be for the APK, the distribution package that you upload to the Android market.
Hi, you mentioned native PVR import. Is that new in 3.1 or was that in 3.0?
Actually, I don't remember. I think it's in 3.0. Yeah, it's in 3.0.
Okay, and I'm also wondering why doesn't Unity just use better PVR compression?
Well, depends. It's not better. You need to tweak it by hand, basically. You can. We are just using some default settings there, and
right.
Ideally, we would like you to be able to preview that, right? But as long as we don't have it so far, in the future we might have a nice interface for that. But so far we just went this solution, just you being able to import the PVR
Okay,
textures.
well, that sounds like a good stopgap.
Yeah. Okay. In the future, we probably will have a better solution for that.
Mark Cohen with Skyview Pictures. This question's for Eric. Will plugins be more streamlined as far as using like native Android stuff instead of having to go through the JNI to native C++ back to the Java?
Yeah, there is a high chance of that we will streamline that. Yeah.
One of the things that was kind of surprisingly missing from the Android SDK was the lack of GPS support. Is that something that is in 3.1 at this point, or is that something that's on the roadmap?
It's definitely on the roadmap. I mentioned a little bit of the normalization of the script API. It's listed under that to-do list. It didn't make it in for 3.1 because of some other more crucial things that we needed to get in, but it will definitely get there.
Are you at a point where you can start to recommend art budgets for the Android platform, such as your Vertex and Skin Vertex is similar to the iOS, or can we make some similar assumptions that we're designing games for the iOS, and they should, in theory, be also working on the Android from an art budget perspective?
Generally, I would say you can go with the same figures. Of course, there are. Like if you look at running the same application on different, especially on different graphical GPUs, graphical processor units, you get you might get a suboptimal frame rate because the GPU might be faster if you would have done it a little bit like setting up your scene a little bit different, but it should run the scene at the target frame rate or about the target frame rate between the different devices.
So one more question, and we should.
Hi, my question is actually for Mark. regarding the port from iOS to Android. I may be doing it wrong, but I've always found had trouble, or I've never found a way to dynamically change font size. So I was wondering if you have any tips regarding font size when dealing with different screen sizes for the different devices.
Okay. Yeah. Well, unfortunately I'm not very technical. I'm doing the art side, but I think we've just been using separate font size. So we started to use now for our latest project the Sprite Manager too, which lets you scale fonts.
Okay.
Thank
so
you.
I think if you have questions, you can talk to us now, or you can meet us in the hands-on session. So thank you, everyone, and bye-bye.